Hi there, this video is a demonstration of the recapping process, which is basically replacing old capacitors on a printed circuit board with new ones. This is the way that I do it. I'm not suggesting that the way I do it is better than anyone else's, but these are the steps that I take whenever I'm doing a recap on any sort of board. So a quick overview of the problem. Electronic devices use capacitors and in particular quite a lot of aluminium electrolytic capacitors. Now this picture here shows all of these are electrolytic capacitors, and the issue with them, all electrolytic capacitors are basically just a tightly wound scroll of layers of aluminium foil, and in between those layers are a paper that has been soaked in electrolyte. And basically the problem is that as these capacitors get old, that electrolyte can leak out of the capacitors. The capacitors stop being effective, and the Gatorade that comes out of them can end up corroding the board. So what ends up happening is after a certain period of time, you see the liquid coming out of the capacitors on the board, and then you know that they have to be replaced. Now what I'm going to be replacing today is a Macintosh Classic II motherboard. Now this is about 25 years old, and pretty much every board that I've ever seen of this vintage does have some capacitor leakage. So don't sort of think that your device is going to be somehow immune to it. Once they get to a certain age, they are going to leak, and the capacitors will need to be replaced. Otherwise, the corrosion, if left untreated, will just mean that your device gets completely and totally destroyed and can never be repaired. So there's been a lot of talk about, and well, I have seen some videos where people have talked about just washing the electrolyte fluid off. This will, in some instances give you a temporary solution, but as it is only a temporary solution, and it doesn't always guarantee that it's going to fix the problem, because although that might remove that electrolyte off the board, it doesn't repair the capacitor, and so you're going to end up with a device that perhaps doesn't work properly, and you're going to probably end up with ongoing leakage as well. So it's not just a matter of cleaning that fluid off the board. You've got to replace the capacitors. Now what I've got here is I'm just going to cross over here to the microscope, and what I've got here is on the left is a surface mount electrolytic capacitor. Now these are the real problems, because so many of these sorts of devices have surface mount aluminium electrolytic capacitors. Now on the left is the capacitor. On the right is the same sort of capacitor, but with the aluminium taken off, so that you actually see what I was talking about before. That you have this brown stuff, which is basically just paper wound up in a little scroll. In between that are layers of aluminium foil, which you might just be able to see there, and this paper is the stuff that's doused in the electrolyte, and that's where the leaking electrolyte comes from. In order to do a recap, what you're going to need are a soldering iron, a hot air rework station, some solder, some flux, solder wick, some fine tweezers, some good lighting, and good eyes and a steady hand are also quite good. And of course, one of the most important things is to have replacement capacitors. Now you can of course just replace your old aluminium surface mount electrolytic capacitors with new ones. Or in the instance of what I will be doing here, I'll be replacing them with tantalum capacitors that don't leak. Another question that you would have to ask yourself would be, should I actually do this? If if this is the first one that you're planning to do, and you're not sure about whether this is a job you're prepared to take on, what I would say about it is, by all means, give it a try. But what I would suggest is, if your board is in reasonably good condition, then I would say that's really the job you would want to take on. If you've got one with really bad corrosion, or if you've actually got components that are actually falling off the board, under those circumstances I would probably recommend finding someone else to do it, just because when the board has already sustained that level of damage, it would probably help to have someone with a bit of experience to in order to either restore some of those damaged pads on the board, or in some instances they would have to be replaced with new traces. So, but having said that, I mean, the first one I did was in a terrible state, and I still managed to complete it. So, so anyhow, the next thing is I'm going to show you this board under the microscope. Now, I use a microscope because my eyes aren't particularly good anymore, but also because it helps me sort of demonstrate the process. But this is something that you can do without a microscope. You might want to use maybe something like this, which is just an illuminated magnifier, something that just allows you to get a reasonable sort of view of what you're looking at. But these components aren't that small, so I definitely think it's something that you can do without a microscope. So let's now have a look at this board. And as we look around here, so here's a little cluster of 4 surface mount electrolytic capacitors, and you can kind of see this corrosion around here, and so around here, and indeed above it. If you have a look here, I'm not sure whether this board may not have actually been cleaned at some stage, but up here you can see all this sort of crusty, crunchy stuff here. That's all residual fluid that has come out of these capacitors at some stage. This really does look like someone has washed this at some stage, but not particularly well. Once I'm finished with the recapping process, I will actually clean the board in an ultrasonic cleaner, which will help get a lot of this gunk off. Okay, so I am going to replace these 4 capacitors here. I'm not going to go through the process of replacing all of them, that would just be too long and boring, but I will just go through the process of replacing these 4 capacitors here. And we've got, if I just change the focus up here a bit, you'll see that we've got this one here is a 10 microfarad 16 volt, another 10 microfarad 16 volt, another 10 microfarad 16 volt, and then this one is a 1 microfarad 50 volt. So before I would do any of this, the very first thing I would do is take a photo of the board with the old capacitors on there, and make sure when you zoom in on the photo that you can actually see all of the numbers on the top of these capacitors, so that when you go to replace them with new ones, you can see where they're supposed to go. There are websites with reference information about what capacitors go where, but which certainly in the instances there, I've had some boards where the capacitor's been so damaged you can't even see the numbers on them anymore. So that's always useful. But as I say, I tend to work from a photo of the original board. The first step we're going to take is to remove these old capacitors. Now, there are a number of ways you can do that. One, of course, would be just using a soldering iron, but the problem with that is that because the capacitors are held on with 2 separate pins, that it's very difficult to apply heat to both of them at the same time. So if you're going to use a soldering iron, you would sort of have to desolder one and then kind of bend it up and then try and resolder the other. And that's not really a process that I would recommend, because that's probably going to result in tearing a pad off the board. And so I wouldn't recommend doing that. You can use solder tweezers, where you actually have tweezers with sort of heat on both tips of it, so that you can melt both sides and then lift it off. But I much prefer to use a hot air rework station. And the hot air rework station basically allows us to sort of just blast very hot air at the capacitors, melts both sides, both pins, and then you can just lift it off. Now, I use a quick 861DW hot air rework, which is a nice balance between sort of quality and budget. But you could do this with one of those real El Cheapo ones. I wouldn't necessarily recommend it, but you could, do this job. These components are quite large, and I mean the main problem with the really cheap ones is they generally don't get a very powerful jet of air and really hot air. They don't come up to quite the same temperature, and they don't blast as a stronger blast of hot air. But I have used those sort of El Cheapo ones before, and you could do this job with them. So I would certainly recommend using that ahead of just you trying to do this with a soldering iron alone. All right, so let's move on to the process of actually removing these capacitors. So I'll just focus a little bit here. Now, one of the issues that I have going on here is right here is the reset button for this computer. And that reset button is plastic. And so if I hit that with hot air, that is going to melt and look unsightly. So what I'm going to do is I'm going to put something in between the capacitors and the plastic there that'll help sort of protect the plastic from the heat. Now I'm using just a flat piece of steel here, and this is actually just the blade from a box cutter. And one of the things that's really great about these is, they're a decent thickness of metal. They're quite good at absorbing the heat. But the other is that because in those box cutters, you can snap them off. So you can snap them to different lengths. And so they're really good for finding a nice length that'll just slot into the space that you have on the board. So here's my little box cutter piece. And I'm just going to slot this in here between the plastic and the capacitors, and that will help protect them. Right, so next thing I'm going to do now is remove them. Now, when you apply the hot air, what it does is it heats up the board, and what that then means is that once that board is heated up, the second, third and fourth one come off a lot easier in that area. So rather than just removing one, when they're in a little group like this, I remove all four at the one time because it's just much quicker and easier to do it that way. So I'll grab my trusty hot air now, and I'll start down here in the corner, and I will just apply some heat to there. And we can see the plastic starting to melt, the plastic around the capacitor starting to melt. And then off he comes. Let's go get the next one. And off he comes. And the next one. And he's gone. And he's gone. Okay, so that's 4 capacitors just came off really, really quickly and easy with the hot air. And if we take our little metal off, you'll see that plastic is absolutely and totally intact, has not been melted one little bit. Now, if we have a look in underneath where those capacitors were, you can see we've got this black crusty stuff going on here. And that's that Gatorade that's leaked out of the capacitor onto the board. And that's one of the things you need to do after this, is inspect and make sure that we haven't got any damage to any of these traces. So this one here, you can see this does appear to still be intact. I will check for sure to see that that is intact, but it does appear to still be intact. So I think that once we replace the capacitors there, we should be fine. So when it comes to putting the new capacitors on, I tend to use a soldering iron rather than the hot air station. And there are a couple of reasons for that. The first is that the tantalum capacitors I use are orange, and when you hit them with hot air they go brown and it looks ugly. It doesn't affect their functionality, but it just doesn't look too nice. The other reason is control. I find that I can get far better control getting the capacitor into a position I want just using a soldering iron, and so that's why I do it that way. Now, when it comes to the soldering iron, I'm using a solder station. I use a Hacko soldering station. You're not going to want to do this with one of those all-in-one soldering irons. You're going to want a proper soldering station, one that can output a reasonable amount of heat. The other thing is I use a bevel tip. So if we have a look at this under the microscope, you'll see that the tip has a flat end. There we go. Has a flat end, has a flat edge there, and I just find that much easier for getting the heat onto what you want than using a pointed conical tip. I don't use pointed conical tips at all, ever. I only ever use different size of bevel tips. That's my soldering iron. The next thing I use is Flux, and Flux is an incredibly important part of this cleanup process. The purpose of Flux is to help solder to flow. You'll end up with much better shape of your solder joints if you're using Flux with it. And I would recommend using it very, very liberally. Now I use Amtech NC559 V2 TF. I have found a few other ones that work quite well, but I quite like the Amtech Flux. It's sort of a gel, and this stuff is like generally no clean. So that is that you can put this Flux on and you can leave it on there, whereas a lot of other Fluxes you have to wash off afterwards. Now I still wash it off afterwards because I think leaving Flux on there just makes the board look awful, but these are designed as a no clean type Flux. And as I say, you want to be really liberal with them because you will just end up with far better solder joints. Then the other thing is the solder. Now I use a leaded solder, but of course you can use a lead-free solder if you prefer. I go with leaded solder because I like to work with the lower melting temperature. Buy a good quality solder, that's what I would recommend. You basically get what you pay for when it comes to solder. So now armed with my soldering iron, my Flux and my solder, I'm going to go set about cleaning up these ugly joints that I've just exposed after removing those components. Okay, so let's start with this one right here. I'm going to just get some Flux onto there and a hair by the looks of it. Let's get rid of that hair, we don't need hair there. Okay, let's get some there. Now I would normally do them all in one go, but I'm going to do just one to start off with, just to demonstrate. So we get some new solder and we just give it a little bit of a rub around like that. Now as soon as you start doing this with the new solder and the Flux, these things generally all start looking way better, like almost straight away. And then the next thing I'm going to do is use my WICK. Now this is solder WICK, and this is a sort of a braided copper that has Flux on it, and it sucks up solder. And I use this as, first of all, to remove that new solder that I just put on as part of the cleaning process. But then I also use the Flux to, clean up the pads, almost like a sandpaper. So I'm just going to grab some of this WICK. I'm going to put it down onto these pads, and I'm just going to gently rub, very gently rub in a circular motion. Okay, just like that. Now, what you can see there is those pads basically coming up looking really nice. Now I'm going to use a cotton bud or a Q-tip with a little bit of isopropyl alcohol. Probably should have included that in the what you will need bit at the beginning, shouldn't I? Bit of isopropyl alcohol. And then with my cotton bud or Q-tip, I'm just going to rub away all the old stuff. I'm getting rid of my Flux and I'm getting rid of all my gunk. Okay. Now, you can instantly see the difference here. Now, here is one of the old scungy black cruddy ones, and here is our nice, clean, fresh one. And as you can see, it virtually looks like brand new. That one is now ready for a new component to be put on. So now we just have to go through the same process for these other three. So I'm just going to do these. Get the old Flux on there, like that. Get our fresh solder, do our little circular motion here and there, and there, and there, and there, and there. Okay. And then we'll grab our solder wick again and just give those a bit of a rub. Now during that rubbing process, you'll see that I'll sometimes take off some of the coating on these traces here, and so they're now have now been tinned with solder. The only thing there is to just make sure that because they're now exposed, you don't want to you know, accidentally create a short by when you put the new components on, touching some of those exposed wires. Okay. Just a little bit more here for the last one. Let's get our, let's do it around that way. There we go. That, give it a little bit of a rub, a little bit of a rub. If you start having trouble, just try putting on either more solder or more flux. All right, so there we've now got 4 nicely cleaned up pads. Just cleaning off all the flux and all the black gunk with my cotton bud in alcohol. Okay, and then we have 4 nice, neat and tidy pads ready for the new components to go on there. Now, you can sometimes end up ones with far worse corrosion than I've just shown there, and with those ones it can sometimes take a little bit of work to get some of the old gunk off. In some instances I've even used like a little scalpel like this, little round edge scalpel, to scrape off some of the old stuff to reveal the copper underneath. But the majority of them will be sort of like this. You know, it's not too hard to clean up. Okay, so the next thing now is to get the new capacitors put in place. Now, as I mentioned before, I have 4 capacitors that need replacing in this section, and they are, let's have a look. So there, 3 of them are 10 microfarad 16 volt, and 1 is 1 microfarad 50 volt. I'm just going to grab my replacements here. So that's 10 microfarad 16 volt times 3, 1, 2, 3, and 1 microfarad 50 volt times 1. Now, time to show you something which is a little bit annoying and confusing, potentially confusing. Here is, oh, no it isn't, I dropped it. Where is it? Here it is. Here is an electrolytic capacitor. Now what you'll see is down one side here, you've got this black stripe. That refers to the negative pin. So that's basically so that you put these on with the correct polarity. If you have a look here, these have got little plus and minus signs on the board showing what the polarity is. So there's your positive there, and so that means your negative is going to be on that side. So if we were putting this capacitor here, we would be putting it with the stripe on the negative side. Tantalum capacitors, they have the stripe on the positive side. So if you're working with a tantalum capacitor, you need to make sure the stripe is on the plus side. So yeah, that's just to add a little bit of extra confusion. You just need to make sure that if you're replacing these with tantalums, that your stripe goes on the positive side. If you're replacing them with electrolytics, your stripe goes on the negative side. All right, so this guy here is my 1, that's my 1 microfarad 50 volt, which is going into that C15 location right here. The first thing I've got to do now is put some flux onto the pads, ready to put the new guy on. So flux goes on, and then the capacitor goes on top. Now these tantalum capacitors are a little bit wider than the capacitors they're replacing, which means you don't have much pad on either side to work with. But that's okay. You just have to be very careful with the positioning, but at the end of the day, it still works fine. So what I basically do is I now get my soldering iron and I get some solder and I just melt some solder onto the soldering iron. So now at the end of that soldering iron has just got a bit of liquid solder on there. Now I get the capacitor, I hold it in position, trying to center it so that I get an equal amount of pad on either side. So I just put that there like that, and then I melt that on. Now, if I give that a nudge, you can see it's well and truly held on one side. So I'm just going to push it down from the top to make sure it's nice and flush with the board, and it is. Wait for it to harden, and there we go. So that one is soldered on one side, ready for solder to go on the other side. But rather than do them one at a time, because I've got to flip the board around to do the other side, what I do is I do all 4 of them one side, and then I flip it over and do all 4 of them the other side. So next thing I need now is one of my 10 microfarad capacitors, and I will need that with the positive on the left hand side. So let's put some flux on the surface, ready to go. There we go. Capacitor goes down in position, and once again some solder onto the tip of the soldering iron, hold the capacitor in position and melt. Okay, it slipped a little bit, so I'm going to try and move it back so that I've got room on this side. Yeah. There we go. Okay, now he's not quite flat, so I'm going to, there we go. So he's flat now, and then again, just to test, I give it a nudge. You can see that it's well and truly held on this side, but not on this side. So there we go. Move on to the next one, and this one here, again positive on the left, and this is another one of the 10 microfarad 16 volt. Oh, I forgot my flux, didn't I? Flux goes down. Why don't I flux this one while I'm at it, eh? Save myself a step. Put that one down there. Once more, bit of solder on the tip. Hold him still. This one's a little bit tricky because I've got my buttons there where I want to have my hands. Okay, there we go. Hold him there. Doop. That's there. I'll push him down, make sure he's flat. There we go. Again, give him a nudge, make sure he's on. Last one, another of the 10 microfarad, and I'm going to, this one here, the plus is on the right hand side, you might notice, so he's got to be around the other way to the others. That goes on there. Again, solder onto the soldering iron. Apologies to anyone who's listening to this who pronounces solder solder. It's obviously solder or solder depending on which part of the world you're from. I'm from one of the solder parts of the world. Okay, it goes on. I'll just again make sure it's flush. Yes, it is. And again, giving him a nudge, he's definitely on there. So what I will do just quickly here, I'm going to just change the focus slightly. And if you look at this one, you can clearly see that solder is on the side of the capacitor, but it's also going down onto the pad on the board. So that one's held in nicely. Okay. Next thing we need to do is do the other side. So flip the board around. Now a little tip for you, if you're ever doing these and you've got a situation where the capacitor is in a difficult to reach position, always solder down the easy side first, because while you're holding it still, if you've got better access, hold it still, do the easy side first, and then do the difficult side second. Okay, so let's start with these two here. Exactly the same process. The only difference here is I don't have quite as much room to move because I've got to get in there, but that's okay. some solder on the tip of it. Again, pushing this down to make sure it's flush. Melt it onto there, like that. Now, I can now give that a nudge, and you'll see, no matter which side I push, it ain't moving. So he's on good and solid. Next one. More solder on the end of the soldering iron. Push it down. Okay. Another push. Yep. He's on solid. Over to here. This one again is a little bit tricky because I've got my button there, so I'm going to probably come in at it. Yeah, I should be fine there. I've got room. Alright, more solder onto the end of the soldering iron. Yep. And that's on. And the last one. Look at that, I melted my button. I'm glad this is my board. Don't mind melting my own boards. Okay, I'm coming at it from this angle so that I don't melt the button any further. There we go. And that's really the angle I should have come in for this one as well, like that. There we go. Right, so that is 4 capacitors that are now soldered onto the board, new capacitors. So whenever I put them on, I always do a series of checks after I've done them. And they are, first of all, have I put the right capacitors in the right place? We can obviously double check that with these codes here. 106C, that is the 10 microfarad 16 volt. 105T, that is the 1 microfarad 50 volt. So you just double check against your photo of the where the old capacitors were, and you double check those to make sure you've got the right ones in the right position. So that's check number 1. Check number 2, always check the polarity. Go over and make sure your stripe is on the positive side, stripe is on the positive side, stripe is on the positive side, stripe is on the positive side. Very, very important. Then last of all, give each one a little gentle push with the tweezers to make sure that they are all on well. They're all nice and solid and they're not going anywhere, and the solder is all, soldering is all done. So, okay, so that's those 4 there. They're all, as I say, I'm not going to demonstrate any more. That basically shows the process. But you can see now we've got 4 new capacitors on there. I'm now going to go through and replace all of the rest, and then after that I will go through and show you the cleaning process, which is also very important to get all of that old Gatorade gunk off the board, and just gives you a much better chance that after the recapping that the board will work. So that's it for this step, this part of the process. So there we have it. 13 capacitors are replaced, and so the next step now is to wash off all the gunk, all of the flux and all of the old corrosion that was on this board, and I'm going to do that with an ultrasonic cleaner. So this is the ultrasonic cleaner here. This is distilled water and a special printed circuit board cleaning solution. It's diluted in the water, and I basically get the board, pop that into a little basket, lower that in. I'm going to give this guy 10 minutes on one side, 10 minutes on the other side, and then I will show you the process of drying it off. Okay, well the board is out of the ultrasonic cleaner now, and it's still got all of the liquid detergent all over it, so I need to rinse that off. Now you could just rinse that in water, but I'm actually going to rinse it in isopropyl alcohol. So this is a little bath of isopropyl alcohol. I'll drop that inside there, and what that does is, first of all, it obviously rinses the board off, but the other thing it does is it displaces any water left on it, pushes it all out of the nooks and crannies so that only the alcohol is left behind. And the great thing about isopropyl alcohol is it evaporates at a very low temperature, so it means that I'll be able to get this board dry and ready for use much quicker than if I were to just soak it with water. I would have to let that dry for some time. What I do to speed up the drying process, I actually put this into the oven. So I put this into an oven at about 60 degrees Celsius. So it's not particularly hot. We're not actually talking about the temperature that we'd use for sort of cooking any food or anything like that. But it's a low enough temperature so that it doesn't melt any of the plastic parts. Things like these reset buttons, they will melt at quite a low temperature. So as I say, I'll put the oven on at about 60 degrees Celsius. I then put the board in for around about half an hour, sometimes a little bit longer, and then after that it comes out completely and totally bone dry. I will then, at the end of that process, I'll show you the board and show you the difference in looking at some of those areas that had all that crusty gunk on it. Okay, so here is the board, clean and dry and recapped, and you'll see that a lot of that gunk that was there before has now gone. So I'm just moving around here some of the other caps that I've replaced there, and these chips here were the ones that had a lot of, you know, scunge and crunchy stuff between the pins, and you can see that's all gone. Still a little bit of residual corrosion there, but basically this is now much cleaner and tidier. There's another cap there, and there's 4 more caps there, and there's the CPU, all those pins looking nice. This has a pretty good chance of working. This is a non-working board. There's no guarantee that what I've just done is going to fix it, but it's certainly worth a try. So I'm going to pop its ROM chips back on and see how it goes. Okay, so this board has been recapped, it's been washed, it's been dried, and now I've connected it up to a power supply to see if it works. Okay, well, we've got a chime, that's a good sign. And there we go, it's booting. Now this Classic II analog board desperately needs recapping as well, but that's a project for another day. I hope there was some information in this video that was of help to someone, and thank you for watching.